So good evening, everyone. Welcome to the session on maths test discussion. We're going to discuss the paper which you attempted yesterday on trigonometry and complex numbers. I welcome each one of you for taking time out and being part of this important session. During the session, I would recommend that you will interact. If you have any doubts, you will ask them as we proceed with the presentation. Is everybody able to see the screen?
Yes, sir.
Excellent. All right. So if you see this particular chapter exam was on trigonometry and complex numbers. Both these chapters being very, very important. And if you take trigonometry, as all of you may know, it has excellent weightage in first PUC. Apart from that, your second year mathematics, some of the most important chapters are going to depend on this chapter. Can anybody tell me what are the chapters in second year that will be dependent on trigonometry?
Differentiation.
Yes, differentiation.
Integration.
Okay, mute yourself. Anybody else? Yeah. Okay. Differentiation, then
Integration.
integration. Yes. Differentiation, integration, inverse trigonometric functions. All right. All these are going to be based on trigonometry, right? So it's extremely important that your basics in trigonometry is very, very good. And complex numbers, what are some of the applications? Anybody can tell me what are the applications of complex numbers?
Sir, complex numbers are used in second PUC physics AC, that is alternative current chapter. Complex numbers are used.
Excellent.
And even in biquadratic equation or higher level of mathematical equations, we use complex numbers.
Absolutely, ma'am. Fantastic. Right. So let's get into the question paper and let's discuss them now. All right. Okay. The first part of the question paper, if you see, were very short questions where you will answer it just by using a formula, just 2-3 steps, right? And each question carries 5 marks. So the first question is 7 pi by 6 radians. Convert that into degrees. This has been asked in first PUC board prepared paper in 2013, 2017 and 2019. Okay. Now, can anybody tell me how I should solve this?
So by degree formula.
Yeah, we have to convert from radians to degrees. So what we must multiply it by?
So we must multiply it by 180 by pi.
Absolutely, right? So as you can see, to convert from radians to degrees, you must multiply divided by 180 by pi. You can see pi and pi will get cancelled. So you get 7 into 180 degrees by 6. 180 by 6 is 30. 7 into 30 is 210 degrees is the answer, correct answer. Clear, students?
Yes, sir.
Yeah. Let's go to the next question. As you can see, the next question has been asked in 2020 board exam paper. If tan x is equal to 3 by 4 and x lies in the first quadrant, find the value of sin x, right? So in the first quadrant, can anybody tell me which are the trigonometric ratios which are positive?
All trigonometry.
All the trigonometric ratios are positive. Absolutely right. Tan x is 3 by 4, tan x is positive, so will be sin x. What is the formula for tan x? Tan x is nothing but if you talk in terms of triangle.
Opposite by adjacent.
Absolutely. Opposite by adjacent is tan x, and that's going to be equal to 3 by 4. What is sin x?
Opposite by hypotenuse.
Exactly. And what is the missing side? Missing side is the hypotenuse, right?
Yes, sir.
And how do you find that?
So the square of adjacent and the square plus square of opposite is equal to the square of hypotenuse.
Absolutely. By using Pythagoras theorem, we are going to get the value of hypotenuse. So what is it going to be?
5, sir.
5, exactly. 3 square plus 4 square. That's 25. Root of 25 is 5, right? So as you can see, tan x is 3 by 4. You can construct the triangle. You can get the value of hypotenuse, right, by using Pythagoras theorem. And once it is done, right? So, you know, that's going to be equal to 3 square plus 4 square within the square root. So that's going to be 5. And sin x is given by opposite by hypotenuse. That's going to be equal to 3 divided by 5. Clear?
Yes, sir.
This was asked in the board examination 2020. Now let's move on to the next question. Convert 240 degrees into radian measure. How do we solve that? Now for converting from degree to radians, what we should do?
Pi
So we
by
should
180 into degree measure.
Yeah, we must multiply it by pi by
Pi by
180.
180.
Exactly, right? Fantastic. So this has been asked in the board examination 2016 and also in 18. Right? So multiplying by pi by 180, you get 4 by 3. So 4 pi by 3 radians would be the answer. Clear?
Yes, sir.
Yes. Let's move on. Let's now look into the next question. Question number 4. Find the conjugate of the complex number z is equal to root 3i minus 1. And this has been asked in the first PUC board exam 2019. Okay. Now, what is the first step?
Change the sign
Change the
of
sign of the
imaginary part.
imaginary part.
Right. So if you see, you can clearly see that first thing is to write it's root 3i minus 1. First write the real part first, minus 1 plus root 3i, which is the imaginary part. Imaginary part is root 3. So you write it in the form a plus ib. If a plus ib is the given complex number, the conjugate is going to be, what is the conjugate going to
A
be?
minus IB.
A minus ib, exactly. Therefore, the conjugate is minus 1 minus root 3i. Clear, students?
Yes, sir.
Yes, sir.
Now let's move on to the fifth question. And this, we have asked it in the first PUC board exam 2020. Find the modulus of the complex number z is equal to root 3 plus I. Now, if I have a complex number z is equal to a plus ib, what is the modulus given by?
Square root of
square
a
plus
square.
b square.
Exactly, square root of a square plus b square. Absolutely. So here you can see modulus of z is modulus of root 3 plus I. The real part is root 3 and the imaginary part is 1. So it's going to be root 3 square plus 1 square within the square root. So root 3 square is 3, 3 plus 1, 4, root of 4 is 2. Clear, everybody? So the modulus of the complex number is going to be given by root of a square plus b square if the complex number is a plus ib. Clear, everyone?
Yes, sir.
Yes,
Yes,
sir.
Emmanuel. Yes. Let's go to the next subdivision. So pretty much quite simple questions, right? In the first 1 mark questions, you must have answered them very quickly,
Yes,
not spending much time. Okay. Now let's move on to the short answer questions, where it may take about 3-4 steps, and each step may carry about half a mark. And 5 questions you're supposed to answer. Each carries 2 marks, so it's 10 marks. So now we have a question which we have asked in the first PUC board exam 2013 in Karnataka. Find the value of sine of minus 11 pi by 3. Right. Can anybody tell me what are the steps involved? Yes.
First split it, sir.
Yes, Avinash. Were you answering? Okay, there is somebody's name who is Galaxy J6. You'll have to change your name to your real name, or else in 5 minutes you'll be removed from the session. Please ensure your name is changed to your real name. And also people who are not on videos, admin may remove you from the session. Get on videos. All right. So let me just discuss this question for you. First step is to deal with the negative sign in the argument, right? By finding out whether it's an odd function or even function. So sine of minus theta, what is it? Is it an odd function or even function? Sine function.
Odd functions. Yeah.
Odd function. So what's an odd function? F of minus x is equal to minus f of x. Therefore, sine of minus 11 pi by 3, first step, what we can write it as?
Minus 7, 11 pi by 3.
Minus sine 11 pi by 3. Absolutely right. Because sine x is an odd function. What's the next step? I can write 11 pi as 12 pi minus pi. Yes or no?
Yes, sir.
Yes. How did I choose 12 pi? It's a multiple of the denominator, right? What is the denominator? You have 3. Preferably an even integral multiple of the denominator. So 3 into 4 is 12. So I chose 12 pi, and that happens to be closer to the 11 pi. So we write 11 pi as 12 pi minus pi. Is that clear to you? In the next step, 12 pi divided by 3 will be 4 pi. So I can write it as sine of 4 pi minus pi by 3. Now, 4 pi can be removed in the next step. Anybody can tell me what is the reason?
Sir, because
Because
after
it's an even number, so every 2 pi it goes back to 0 on the quadrant, so you can remove it as the value 0.
Right. So point is, every time I add another 2 pi, it's not necessarily comes to 0. Every time I add a 2 pi, it comes to the same position where it was originally. So angle is unaltered. So 4 pi, when I say it is like revolving to reach the same point, revolving 2 times. For example, so if you see here, this is my minus pi by 3 here. If I'm going to revolve at 360 degree, I'll come back here to the same line. I revolve once more 360 degrees. Again, I come back to the same ray here, OP, if I call it. Is that clear? So adding a 2 pi to the argument or 4 pi to the argument does not change the ray position. Is that clear to you?
Yes, sir.
yes, sir.
All right. So now if you see, I can take off this 4 pi and write it as what? Minus sine of minus pi by 3. And now how can I write what is sine of minus theta?
Minus sine theta.
Minus sine. Already there is a minus sign, so it will become
Plus sine theta.
plus sine theta. Exactly. So is that clear to you?
Yes, sir.
Yes. So sine of 2n pi plus theta is going to be sine theta itself. Therefore, I remove that 4 pi. And minus sine pi by 3 is going to be simply sine pi by 3. Sine pi by 3, we know the value. What is it?
Root 3 by 2.
Root 3 by 2. So that's going to be your answer. So if you see, each step would carry about half a mark. So you applying the sine of minus x as minus sine x, half a mark, then writing it in this form. No, sorry. Just a second, students. Yeah. Just writing it in the form of 12 pi minus pi, or rather 4 pi minus pi by 3 will carry half a mark. And then once again, removing that 4 pi, again another half a mark, and final result is going to be half a mark. Is that clear how the mark distribution is?
Yes, sir.
Yeah. Now let's move on to the next question. And this is one of the basic identities, all right, which we expect you to remember as well. But nevertheless, you must also know how it is going to be derived. So this has been asked in the board examination 2014 and also in 2020. So what is sine 2x?
2 sin x cos x.
2 sin x cos x. That's where we start the sum with. So we started with absolutely right, Emmanuel. So it is 2 sin x cos x. Now what we do next is, of course, we take a 1 to be there in the denominator, which is fine, right?
Yes, sir. Because it remains.
Yes, it does not change the equation, right? And 1 can be replaced with cos square x plus sin square x. Because we know that sin square x plus cos square x is
1.
1. Absolutely. Now, next step, we are going to divide numerator and denominator with cos square x. The reason we do this is because we want to get it in terms of tan x. So here you can see cos x and cos square x. There is one cos x getting cancelled here. And then this cos square x by cos square x becomes 1. And sin square x by cos square x becomes tan square x. So you get 2 tan x divided by 1 plus tan square x. Is it clear to you?
Yes, sir.
So here, as you can see, you're writing this as cos square x plus sin square x, carries half a mark. And then you dividing by cos square x again, carries half a mark. And then writing it in this form, final form, bringing it to the final form, half a mark. And initially writing sin 2x as 2 sin x cos x is going to carry half a mark. Is it clear to you?
Yes,
Yes,
sir.
sir.
Yes, students. So you should not write more number of steps. One other way of answering this question would have been, you can come from right. You could have started from RHS to LHS also. Tan x you could have written as what?
Sin by
Sin by
cos.
cos. Tan square x could have been written as sin square by cos
Sin
square.
square by cos square.
Take LCM. Then you would have seen sin square x plus cos square x here. It will be 1. Then this cos square x, this cos x will cancel. So you can, you can take this to the numerator. You'll get 2 sin x cos x plus divided by 1. And that will be nothing but sin 2x. So you could have come from RHS to LHS also. Clear, students?
Yes, sir.
Yes.
Yes, sir.
All right. Now let's look into the next question here. Question number 8. This has been asked in first PUC board paper of Karnataka 2014. Find the modulus and amplitude of the complex number z is equal to minus 1 plus I. Okay, this is a very common question. And what are going to be the steps? So first step, modulus, we know if a complex number is going to be a plus ib, then what is the modulus given by?
Root of a square plus b square.
Exactly, root of a squared plus b square.
So the answer is root 2.
Yes, you're right. So the answer is going to be root 2. You're correct. So finding the modulus would be awarded 1 mark. Next, we come to the amplitude part. So there are a couple of methods using which you can find the amplitude. In this discussion, I'm going to cover both the methods. So one of the methods, let me teach you here, is finding through this method, which I'll call it as a faster method, okay, which you can also use it for entrance exams, okay. Now, alpha is equal to tan inverse of modulus of y by x. So as you can see, in your given sum, if z is equal to x plus iy, which is minus 1 plus I, can you tell me what is x and what is y? X is minus 1 and y is 1, right? So it will become tan inverse of 1 divided by minus 1. So you get minus 1, but then I recommend you to take the modulus. So that will become 1. So you get tan inverse of 1. What is the angle alpha for which tan alpha is 1?
Pi by 4.
Pi by 4, right? 45 degrees, correct? So pi by 4 is going to be the angle alpha. Remember, students, this is not the final answer. This is not the amplitude of Z. Okay. We have just found the angle alpha. Now, next step is to find out which quadrant the complex number is there. In which quadrant is the complex number existing?
Second
It is in the
quadrant.
second quadrant. Why is it so? Because the point is -1, 1, correct? X is
Yes, sir.
-1, Y is 1. So if I plot this complex number on the Argand plane, what is an Argand plane? Which has all
the points have a complex number assigned to it.
yes, all the complex numbers are going to be placed on that plane. Along the x-axis, you are going to have the real axis. Along the y-axis, you are going to have the imaginary axis. All right. So your argument of Z is going to be given as theta, and that will be 180 minus alpha. If the quadrant we are talking about is what? Second quadrant. Can you guys tell me what is it going to be if the quadrant changes? So if it's in the first quadrant,
formula will change, sir.
yes, ma'am. So can you tell me? I found the value alpha, let's say. But if my point is in the first quadrant, then what will be your theta?
Alpha only, sir.
Alpha itself. Suppose my point is in the second quadrant.
180 minus alpha.
180 minus alpha or pi minus alpha. What if it is in the third quadrant?
Minus
Minus
pi
pi
plus alpha.
plus alpha.
Excellent, Jeril, excellent, Meda. What about fourth quadrant?
Minus
Alpha.
Yes, Emmanuel, right. So that's minus alpha, right? So this is something which you can use so that you can get the argument of Z very quickly. Okay, fantastic. So that's nothing but pi radians minus alpha is pi by 4. We already got it. So your argument is going to be 3 pi by 4. Is it clear to you, students?
Yes, sir.
Yes, sir.
Excellent. Now let's move on to the next question. Another question from complex numbers. We have asked this in the first PUC board exam 2015. Express 1 plus I divided by 1 minus I in the form of A plus IB. It's a very, very important idea, not only for your board exam, but also for your competitive exam, because 1 plus I by 1 minus I, you must know what it is going to become. Okay, we'll see it in the question shortly. Once you write it in the form A plus IB, then find the least positive value of n for which 1 plus I by 1 minus I, the whole power n will be equal to 1. Okay. So first, for writing it in the form A plus IB, you'll be awarded 1 mark. And finally, for finding the value of n, you'll be awarded another 1 mark, making it 2 marks. So any idea what we should do first?
We should rationalize.
Rationalize, absolutely. So you must multiply and divide by the conjugate of the denominator. What is the purpose of doing that?
To remove the I from the denominator.
Exactly, right, Jaril, right, Meda, that's correct. So the imaginary part which is there in the denominator will be no longer there the moment you do this, right? So you can see denominator is 1 plus I into 1 minus I. So that becomes, yes, Avinash, could you tell me what does it become? Denominator.
Denominator 1 square plus 1 square and less.
Fantastic. 1 square plus 1 square, that becomes 2. Okay, in the denominator. And numerator, you are going to have 1 plus I the whole square. So that you can solve using A plus B whole square. Right? So denominator explanation is A plus IB into A minus IB can be directly written as A square plus B square. Or you can use this idea, the idea which is Z bar is mod Z whole square. Okay. Now numerator, we are writing it in the form A square plus B square plus 2AB. What is the value of I square?
Minus 1.
Minus
Exactly. Right? So 1 and minus 1 cancel. So 2I by 2 becomes equal to I. So it's very important, students, for you to remember that 1 plus I by 1 minus I is going to reduce to I. Okay. Now, this is the first part of the question. Second part of the question is your 1 plus I by 1 minus I power n, or rather I power n must be equal to 1. Can you guess what should be the value of n so that I power n will be 1?
So do you write it as 0 plus 1i or just I?
It doesn't matter. It doesn't matter. You can simply write it as I as well. If there is any specific requirement, then you write it as 0 plus I.
Sir, is n equal to 0?
Yeah. So here the point is, it's clearly given. Good answer. But then that is not the answer for this question, because they've asked you, they want, you can say 0 is a trivial answer, but that's not the answer we want. We want the least positive value. If they had not mentioned that, you could have told n is equal to 0. Okay. Of course, 0 is non-negative, but it is not positive, right? Clear, Jerry?
Yes, sir.
Yes. Therefore, 0 is not an answer. Okay. So what could be the positive value for n?
4.
4 is absolutely right. Yes, Rishika. Because I power 4 is going to be 1, because I power 4 you can write it as what? I square into I square. I square is minus 1. So minus 1 into minus 1 becomes 1.
Yes, sir.
So that's the least positive integer. So nothing below 4 can be an answer for this question. So it's 4. 4 is the right answer. Are you all clear?
Yes, sir.
Can anybody tell me the next possible answer?
8, sir.
Absolutely, Jeril. Fantastic. 8. What else?
16.
All the multiples of
All the multiples of
Fantastic. Fantastic.
12.
All the multiples of 4. All the integral multiples of 4 are going to be answers where I power n will be equal to 1. But here the question is very clear. Find the least positive value there. It's very clear, right? So it has to be only 4 and nothing else. So that's the answer. Okay. Clear to everybody?
yes, sir.
Yes,
Okay,
sir.
great. Let's move on. Okay, now we come to the 10th question. If x plus iy is equal to root of a plus ib divided by c plus id, prove that x squared plus y squared is equal to root of a square plus b square by c square plus d square. Now this we have asked in the first PUC board exam 2017 in Karnataka, right? Now any idea how we can proceed with the sum? The easiest approach is to take modulus. Okay, first we'll square it. Okay. So first we'll square both sides. All right. So when you square, when we square it, in the right hand side, what is gone?
Root, sir.
Root is going to be gone. Yes. So we're going to have simply a plus id divided by c plus I, a plus ib divided by c plus id. Left hand side, we're going to have x plus iy whole square. Correct. Now what's the next step? We're going
We
to
need to
take
take the
modulus.
modulus.
Yes, we're going to take modulus on both sides. When we take modulus on both sides, from property we know mod of z1 into z2 can be written as mod z1 into mod z2. Similarly, mod of z1 divided by z2 can be written as mod z1 divided by mod z2. So individually we can take the moduli, right? So I hope this is clear to you.
Yes, sir.
From here to here, yes. Now next we know, right? What is mod of x plus iy?
Root of x squared plus y squared.
Root of x squared plus y squared, correct. And what is mod of a plus ib? Root of a squared plus b squared. That's it, right? So already the right hand side we already got, right? LHS also, if you see, root of x square plus y square into the same will give you what? X square plus y square, and that's going to be our required answer. Is this clear, students? Half a mark for squaring, half a mark for taking modulus on both sides, half a mark for splitting them, that's important, right? This again, you're using a property, and finally getting to the final answer, another half mark. So you get 2 marks. Shall we move on?
Yes, sir.
Yes. Now we move on to the next part of the paper, which is short answer questions, second type. So now here you're going to have 5 questions, each carrying 3 marks, amounting to 15 marks. So this may have anything from 4 to 6 steps. And you should not be spending a lot of time as a 5-mark question. Okay. So you must ensure the 2 marks, 3 marks, and all that are given due importance. And 5 mark, you must find enough time to complete the paper. Okay, let's look into the 11th question, which we have asked in the PU board, first PU board paper in 2014 for Karnataka. Prove that cos of 3 pi by 2 plus x into cos of 2 pi plus x, the whole into cos of 3 pi by 2 minus x plus cot of 2 pi plus x. Prove that this is equal to 1. Okay. For this, a good understanding of allied angles is a must. So first thing that we need to know is Astc rule, right? What is Astc? In the first quadrant, all trigonometric ratios are
Positive.
positive. And in the second quadrant,
Positive.
Sine and its
sine and its
reciprocal.
reciprocal are positive. Sine and cosec. In the
Tan and its reciprocal.
tan and its reciprocal in the third
And
quadrant, and
cos
cos and
and-
its reciprocal secant in the fourth quadrant are positive, right? Okay. Now, if I consider x to be an acute angle, then 90 degrees minus x or pi by 2 radians minus x will lie in which quadrant?
First quadrant.
X lies in the first quadrant, okay? Then 90 minus x also lies in the first quadrant. 90 plus x will lie in the
Second
second
quadrant.
quadrant. 180 minus x also lies in the second
Second.
quadrant. 180 plus x lies in the
Third quadrant.
third quadrant. 270 minus x is also going to lie in the third
Third.
quadrant. 270 plus x lies in the fourth.
Fourth quadrant.
360 minus x lies in the
Fourth quadrant.
fourth quadrant. 360 plus x will go to
The
First
first
quadrant.
quadrant.
first quadrant. Excellent. This knowledge is extremely important, right? So we'll split the sum into 3-4 parts. Once you know it, it's a very easy sum to solve. Quickly you can solve this sum, right? So cos 3 pi by 2 plus x. First thing that you have to analyze is 3 pi by 2 plus x. Which quadrant it lies? Which quadrant does it lie?
Fourth quadrant.
Fourth quadrant, exactly.
So minus
Angle 3
sin
pi by
x.
2 plus x lies in the fourth quadrant. What about cos function? Is it positive or negative?
Positive, sir.
Yes,
Positive.
cos function is positive. Yes. Now, once that is determined, second thing that you have to look at is 3 pi by 2. For 3 pi by 2 plus or minus theta, whether the trigonometric ratio will remain the same or will it change to co-ratio? What do you think?
Will it change, sir?
Change to co-ratio.
It will change to co-ratio. Absolutely. Because 3 pi by 2 is an odd integral multiple of pi by 2. Trigonometric ratio will change to co-ratio. What is the co-ratio for cos?
Sine.
Sine, exactly. So cos will change to sine. So cos of 3 pi by 2 plus x will be nothing but plus sine x. Are you all clear with this?
Yes, sir.
Yes, sir.
That's the first part. Okay. Similarly, we're going to do for the other ones as well, remaining ones. So second one is cos 2 pi plus x. 2 pi plus x lies in which quadrant?
First quadrant.
First quadrant. And cos is
Positive.
Positive.
positive. 2 pi is an even multiple of pi by 2. Therefore,
The
trigonometric ratio will change or it will remain same.
it
It
will not.
remains the same. It will remain the same.
It will remain the same. It will not change, right? So what is the answer?
Cos x.
Cos
Cos
x.
x.
Exactly. So T ratio will remain the same. Your cos of 2 pi plus x is going to be cos x. Absolutely. Very good. Now two more, right? For each of these things, it's half a mark. Okay. You don't need to write all these steps. Okay. So the moment you write cos of 2 pi plus x equal to cos x, that should be good. Okay. Now cot of 3 pi by 2 minus x. Can you tell me what it is? 3 pi by 2
tan
minus x lies in?
Tan x.
Tan x.
Yeah, 3 pi by 2 minus x lies in?
Third quadrant.
Third quadrant,
Third quadrant cot is,
positive.
Positive.
and
Positive.
because it's 3 pi by 2, does the trigonometric ratio change to co-ratio or not?
It changes to quadrature.
Changes to tan. So cot of 3 pi by 2 minus x is equal to
Tan x.
tan x. Excellent. Fantastic. So tan x is going to be the answer for the third one, right? Then we come to the last one, cot 2 pi plus x.
Does it stay cot x?
It's simply cot x, right? 2 pi plus x is first quadrant. First quadrant, all trigonometric ratios are positive, and cot will remain cot because it's an even integral multiple of pi by 2. You're absolutely right. Therefore, it's going to be cot x. Now, all these 4 steps, half a mark each. So you get 2 marks. And now we go to the solving part. You're just going to substitute all of that, what you got. And the solving part is going to be given, awarded 1 mark, where you write, this is tan x as sin x by cos x. This is cos x by tan x. Simplifying this, cancelling your sin x, cos x on both sides. Sin square x plus cos square x becomes
1.
1.
One,
That's
sir.
going to be your answer. This comes from the topic called allied angles. Very important topic. So we have this question asked in 2014. Clear to everybody?
Yes, sir.
Yes. Let's move on. Let's go to the next question, which we have asked in first PUC board exam 2015. If sin x is equal to 3 by 5 and cos y is equal to minus 12 by 13, where x and y both lie in the second quadrant, find the value of sin of x plus y, right? So here what will come in handy is, of course, you can graduate from your definition, knowing the definition of sin x, cos x and all that as in terms of triangle, correct? You can also learn, suppose if you just know a ray, let's say this is our x-axis and this is your y-axis. And let's say this is a ray, OP, which makes an angle theta with a positive x-axis. Let's say the distance of this point P from O is R. And the x-coordinate and y-coordinate at this point are x and y. This we will call it as abscissa. The x-coordinate is called abscissa. The y-coordinate is called ordinate, and r is called the distance. Now, in terms of these coordinates, can you define sin theta? Sin theta is defined as ordinate by distance. What is going to be cos theta? Abscissa by distance. What is tan theta? Ordinate by abscissa.
Yes, sir.
Okay. Now, what is the benefit of having this definition? The moment you have this definition, you don't have to, talk about angles which are only less than 90 degrees. Suppose my point is here, okay, where the angle is much larger, right? Even in this case, you can find out tan, cos, sin, everything just by knowing the ordinate and abscissa and the distance. Is it clear, students?
Yes, sir.
Yes.
Yes. Now, let's understand this. Okay. So sin x, we can write it as sin x is given 3 by 5. We can write it as ordinate by distance. So here, if you see, ordinate by distance. So that's nothing but 3 by 5. Okay. And you can definitely find out the other point, right, which is 4. Yes or no? Magnitude wise, 3, 4, 5 are the Pythagorean triplet, right? Yes, everybody? 3, 4, 5.
Yes, sir.
Yes. So the other point is 4. But then because it is in second quadrant, x is negative. So the point is not 4, 3, but it is what? Minus 4, 3. Correct? And the distance
Yes,
is 5. So can you tell me what is going to be cos theta or cos x? Cos x is what? Abscissa by distance. What is your abscissa here?
minus 4 by 5.
Exactly. Minus 4 by 5 is correct. So you got sin x is given. You found cos x as well, right? On the other hand, you could also use triangle, okay? Next, let's say we are given cos y is equal to minus 12 by 13, which is nothing but from our definition, abscissa by distance. Now, if I plot the point, right, what is going to be the other unknown side?
5.
5, right? And it's the second quadrant. Your abscissa is minus 12 negative, but ordinate is going to be positive, correct?
Yes, sir.
Yeah. So how is it going to look like? Are you clear? So the point is going to be minus 12, 5. The angle is y. And the hypotenuse of the triangle, in case if you use the triangle concept, or the distance is 13. So now cos y is abscissa by distance, which is minus 12 by 13. Can you tell me what is sin y?
5 by 13.
5 by 13, ordinate by distance, absolutely. So we know sin x is given, cos x we found, cos y was given, we found sin y, right? Now substituting them and solving. So whatever we got, we are substituting here. Sin x was given, cos y was already given. So these two were already given, so we write them. These two we found out, we are substituting them here. Denominator LCM is 65. Numerator, you can simply add the minus 36, minus 20. So you get minus 56. Yes. For finding each of them, you are finding cos x, 1 mark. For finding sin y, 1 mark. And for solving this, 1 mark. So you get 3 marks for this. Is it clear to everybody?
Yes, sir.
Yes, sir.
All right.
Yes,
Now
sir.
let's look at the next question, which is a question on quadratic equations and complex numbers. If x plus 1 by x is 2 cos theta, show that x is equal to cos theta plus or minus I sin theta. A very simple sum on quadratic equations. So let's take the question here. X plus 1 by x is equal to 2 cos theta. Now, as you can see, if I take LCM here, x square plus 1 divided by x is equal to 2 cos theta, or x square plus 1 will be equal to 2x cos theta. Or I can bring this 2x cos theta this side, right? So it becomes x square minus 2x cos theta plus 1 equal to 0. This is a quadratic equation in x, correct? I can compare this equation with our well-known ax square plus bx plus c equal to 0. And what is the solution for x? How do we solve for x?
Using the formula method.
Yeah, minus b plus or minus root of b square minus 4ac by 2a. If I compare these two equations, what is my a? 1. B is minus 2
Minus
cos
2
theta.
cos theta.
C is 1. So we're going to use this formula here, substitute the values. B is minus 2 cos theta and A and C are 1 each. So I substituted here. So minus of minus here will become plus. Minus 2 cos square theta, cos theta whole square will become 4 cos square theta. That's what we got here. Here I can take a minus 4 outside, or I can take 4 outside. A minus 1 outside, then it becomes 4 minus 4 cos square theta. And I take a 4 also outside. I get 4 into 1 minus cos square theta. Now things become very easy. What is your minus root of minus 1?
I.
I. What is root of 4?
2.
And what is 1 minus cos square theta?
Sin square theta.
Yes, because sin square plus cos square is 1. 1 minus cos square can be written as sin square. Root of that will be sin theta. We are going to get 2 cos theta plus or minus root minus 1 is I. Root of 4 is 2. 1 minus cos square theta, root is sin theta. Is it clear to everybody?
Yes, sir.
Then the 2 I can take out in the numerator and it can cancel with the 2 in the denominator. I get the answer cos theta plus I sin theta. Is it very clear to everybody?
Yes, sir.
Any
Yes,
doubts
sir.
so far?
No, sir.
Excellent.
No,
Okay, let's move on to another question, which we have asked in the first PUC boards 2013 and also in 2018. This is based on transformation formula. What is transformation formula? Anybody can tell me?
Sin x plus sin y. cos
Yeah,
y.
sin x plus sin y. How can I write this as?
2 sin x.
Yeah,
X
2
minus
sin
y by 2.
by
x
Cos
plus y by
x
2
minus y
into
by 2.
x minus y by 2.
cos.
X
X minus y by 2.
Excellent. Very good. Similarly, here we're going to only use these two, that's all. Cos x plus cos y. So what is that going to be?
2
2
cos x plus y by 2
cos x minus y by 2.
Exactly. Cos of x minus
X
y
minus
by
y by 2.
Okay. Now, one simple thing is, if you just rearrange these terms slightly, you will get the answer faster. Instead of doing it twice or thrice, you can do it once and you can pretty much get the answer. Okay. For example, let me tell you, if you're going to combine these two, right? Can you look at the angles here? If you write sin 7x first and sin 5x next, what is the addition of the two? 12x divided by 2 will be 6x. Makes sense. So we are supposed to get what?
Tan 6x.
So it makes sense to combine those two. And similarly, you can combine the other two as well. Like the 3x part and 9x part. So what will happen again if you see, when you use the formula, 9x plus 3x is 12x, 12x by 2 will be 6x, correct? So that will be a smarter way to do the sum, okay? You will just do once, you will just apply this formula once and you will be done, okay? Anyways, so let's get started. So did you see how I have clubbed these?
Yes, sir.
7 and 5 have clubbed together, 9 and 3 have clubbed together. I have written the bigger angle first, right? So that there are no negative answers for us. So you can see I have just applied the formula which we have written down. So 2 sin 7x plus 5x by 2 into cos 7x minus 5x by 2 plus, for these two also I applied the same formula. Denominator 2 cos c plus d by 2 or x plus y by 2 into cos x minus y by 2 2 times. Clear to everybody?
Yes, sir.
Yes.
Yes, sir.
So see what has happened? This becomes 2 sin x, sin 6x cos x plus 2 sin 6x cos 3x divided by 2 cos 6x cos x plus 2 cos 6x cos 3x. Now what can I take out common from the numerator? 2 sin 6x, correct? Then what will be inside the bracket?
Cos x.
Plus cos 3x. Denominator, what I am taking out?
2 cos 6x. Sir.
Yeah, so what will be remaining?
Cos x plus
Cos x. Cos
Exactly. So what can be cancelled now? 2 and 2 is cancelled.
2 also.
Cos x plus cos 3x is cancelled. So what do I get?
And 6x.
Directly we get tan 6x. Are you clear now?
Yes, sir.
Yes, that's all. So for writing this down, suppose if you're doing it this way, right? Then I can say, even just shuffling, I can give you 1 mark. Then for applying the formula, 1 mark. And simplification, 1 mark. All right? People need to be on mute, guys. Okay. Is it clear? Any doubts in the sum? Clear, everyone?
Yes, sir.
Yes, excellent. Okay, let's go to the next one. This we have asked in the first PUC board exam in the year 2016 and also in 17. Express the given complex number z is equal to minus 16 divided by 1 plus I root 3 in the form a plus ib. First step. Then find the modulus and amplitude of the complex number and express it in polar form. Okay. So first converting it into the form a plus ib carries 1 mark. Finding the modulus and amplitude and expressing in polar form constitutes 2 marks. So first thing is to write it in the form a plus ib. I need to multiply by the conjugate of the denominator. Multiply and divide. So you can see 1 plus I root 3 into 1 minus I root 3 becomes 1 square plus root 3 square. Minus 16, minus into minus is plus I root 3. I can take common. Okay, there is a 16 missing here. So this was 16 here. Okay. So I can take a 16 outside common. So it becomes minus 1 plus I root 3 by 4. So 16 and 4 cancel, giving you a 4 here. So 4 into minus 1 plus I root 3 is going to be the first part. Writing your complex number. So can you tell me what is the real part? What is x?
Minus 4.
Minus 4.
Minus 4. What is your imaginary part?
4 root 3.
4 root 3. Absolutely. Yes, students. Now, let's move on further. Okay, now I want you to understand, visualize, right, how it is going to be in the Argand plane. So this is your Argand plane. This need not be presented in the exam, but I just wanted you to understand it better. So this will contain, this is the positive real axis, negative real axis, positive imaginary axis, and down will be your negative imaginary axis. The point that we are talking about is minus 4, 4 root 3. So minus 4 will be along the negative real axis and 4 root 3 will be the height. 4 root 3 is close to 7, almost 6.9, right? So that's where the complex number is. The distance from the origin to that point is called the modulus of the complex number, or you can call it as R. Clear? So which is nothing but the distance of that point from the origin. So that will be nothing but the hypotenuse of the right angle triangle, right? So it will be this square plus this square, right? So that's what we call as modulus. Okay. So just to give you an idea, I have just shown you this diagram as well. Okay, so modulus of z. So z is equal to x plus iy. So what is modulus of z? Square root of x square plus y square. So minus 4 whole square plus 4 root 3 whole square. Minus 4 square is 16. 4 square is 16. Root 3 square is 3. So 16 into 3 becomes 48. So 16 plus 48 is 64. Root of 64 is 8. Therefore, what is the modulus? 8 units. Clear to everybody?
Yes, sir.
Yes.
Sir.
Now, amplitude of the complex number, let's find. Here I am going to give you the r sin theta, r cos theta method, but nevertheless, you can use the tan inverse modulus of y by z method also. Okay. So amplitude of z, how do we find? If you just compare with r cos theta plus I sin theta. So what is your z here? Your z is minus 4 plus 4 root 3i. So if you compare it with the polar form of writing a complex number, r cos theta plus I into r sin theta. If you compare, what is your r sin theta? 4 root 3. What is your r cos theta? Minus 4. And r we found, which is magnitude modulus, which is 8. So it is 8 cos theta is equal to minus 4. So cos theta is minus 4 by 8, which is minus 1 by 2. Right? Let's find out sin theta as well. Okay. We see that r sin theta is equal to 4 root 3. R is 8. We just found it out. So sin theta is equal to 4 root 3 by 8, which is root 3 by 2. See here. Now sin theta is positive and cos theta is negative. So which quadrant is our complex number in? Minus 4, 4 root 3. Which quadrant? Already we saw it, right?
Quadrant, sir.
Second quadrant, right? So second quadrant, your angle is going to be, suppose normally what is sin theta equal to root 3? What is acute angle theta? For what angle sin theta is root 3 by 2? Acute angle. 60 degrees.
60, sir.
Pi by 3. All right. Because it is in the second quadrant, you will take pi minus alpha. I hope you remember. So your answer will be pi minus pi by 3. Or in other words, 120 degrees. And you already know cos 120 is minus 1 by 2. Correct? So your theta is going to be not pi by 3, but what? Pi minus pi by 3 because it is in the second quadrant. Your alpha is pi by 3. So this angle is 120 degrees or 2 pi by 3. Clear to everybody?
Yes, sir.
Yes.
Yes, very good. Very good. So this is the answer. So you got your modulus, which is 8. You got your angle, which is 2 pi by 3. So answer will be Z is equal to 8 into cos 2 pi by 3 plus I sin 2 pi by 3. So polar form is R into cos theta plus I sin theta, 2 pi by 3. So 8 into cos 2 pi by 3 plus I sin 2 pi by 3. Is it clear to you?
Yes, sir.
Yes, sir.
Yes, very good. Now we come to the last question. So there is one question which carries 5 marks. Now in this case, we had given 5 subdivisions for the same question. Prove the following trigonometric identities. First question, let's go into sin 2 theta is equal to 1 minus cos 2 theta. Sin theta divided by 1 minus cos 2 theta to be proven to be equal to cot theta, right? So can you guys tell me what are the formulae for sin 2 theta? Can you tell me?
2 sin theta.
2
cos
sin x into
Oh.
cos x.
Very good. 2 sin theta cos theta. Is there any other way I can write sin 2 theta?
2
2
tan
tan
x.
theta divided by 1 plus
Theta by
tan square
1
2
theta.
tan
plus
theta
tan
divided by
square
1
theta,
plus
very
tan
good.
square theta.
Yes. What are the different ways in which I can write cos 2 theta? Because these are very, very important, okay? Cos square theta minus sin square theta.
2 cos
One.
square.
Very good.
Theta.
2 cos square theta
1 minus
1.
2 sin square
1
theta.
minus
1 minus 2
Sin square theta.
sin square theta.
1 minus tan square theta by 1 plus tan square theta.
Excellent. 1 minus tan square theta by 1 plus tan square theta. All these are possible, right? So here, if you see, in this question, we are going to write the numerator as what? Sin 2 theta is equal to 2 sin theta cos theta. We're going to use that. And we are going to use the second part, if you see. Cos 2 theta is equal to cos square theta minus 1. If you rearrange it, and in fact, in this sum, we are using the third one, okay? If you just bring 2 sin square theta here and cos 2 theta here, you can see that 1 minus cos 2 theta can be written as what?
2 sin square theta.
Cos
Absolutely.
2 theta.
Exactly. So 1 minus cos 2 theta can be written as 2 sin square theta. Exactly. So 1 minus cos 2 theta, I am writing it as 2 sin square theta. And sin 2 theta, I am writing it as 2 sin theta cos theta. Is it clear to you?
Yes, sir.
Yes, sir.
Yes. So what will cancel? 2 will cancel here. 1 sin theta will cancel. So cos theta by sin theta, what is it going to be?
Cot theta.
Cot theta.
Cot theta.
That's all. Of course, all these formulae you need not write for this question. As long as you understand 1 minus cos 2 theta is 2 sin square theta. Clear, everybody?
Yes, sir.
Yes, sir.
Yes, that's all.
yes.
Next one. Sin 2 theta by 1 plus cos 2 theta. So this time, what are we going to use? We're going to use this one. Cos 2 theta is equal to cos square theta minus 1. If I take this minus 1 that side, what will you get?
1 plus cos 2.
1 plus cos 2 theta will be equal to what?
2 cos square.
2 cos square theta.
Cos square theta, exactly. So 1 plus cos 2 theta, I can write it as 2 cos square
2
theta.
cos
Now
square
what will get cancelled? 2 gets
and
cancelled. 1 cos
1
theta gets cancelled. So I get it as
tan
tan
theta.
tan theta. Are you clear?
Yes.
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 Sir.
Yes. Any doubts?
No, sir.
Okay.
No, sir.
Now let's do the third one. 1 plus sin 2 theta plus cos 2 theta divided by 1 plus sin theta minus cos 2 theta is equal to cot theta. We need to prove. Do one thing. Just write these two terms together. That will help you. Okay. That's what I did. 1 plus cos 2 theta you write together. 1 minus cos theta you write together. We just saw what is 1 plus cos 2 theta.
cos square theta.
2 cos square theta. What is 1 minus cos 2 theta?
2 sin square
2
theta.
sin square theta. Exactly. And what is sin 2 theta?
2 cos
2 sin theta cos theta.
Exactly. So that's what we are going to do. So in the numerator, what can we take common?
2 cos theta.
2 cos theta can be taken out common. In the denominator, we can take
2 sin theta.
2 sin theta common. So what will get cancelled? Sin theta and cos theta will cancel. The 2 and 2 will cancel. So cos theta by sin theta, that is going to be cot theta, which is your.
Cot theta.
Clear? Simple?
Yes, sir.
Yes.
Yes. Next, let's look at the other identities. Root of 1 minus cos 2 theta divided by 1 plus cos theta should be equal to tan theta. So what is your root of 1 minus cos 2? What is 1 minus cos 2 theta?
2 sin squared.
2 sin square theta. What is 1 plus cos 2 theta?
2 cos squared theta.
2 cos square theta. Yes. So root of sin square theta is sin theta. Root of cos square theta is cos theta. Sin by cos becomes
Tan.
clear, everyone?
Yes, sir.
Yes, sir.
Excellent.
Yes, sir.
Great. So now let's come to the last part. Tan of pi by 4 plus x, prove it to be equal to 1 plus tan x by 1 minus tan x. Very, very simple. We know what is tan of x plus y. So can anybody tell me what is tan of x plus y?
Tan x plus tan y by 1 plus tan x.
Yes. So this can be written as tan x plus tan y, the whole thing divided by 1 minus
Tan x, tan y.
tan x tan y, exactly. So here, only thing is your x is pi by 4 and y is x. So this will become tan pi by 4 plus tan x divided by 1 minus tan pi by 4 into tan x. Just by using this formula, right? And what is tan pi by 4?
1.
1. So it becomes 1 plus tan x divided by 1 minus tan x, and that's what we needed to prove. Is it clear, students?
Yes, sir.
Yes. Of course, the other question has been is a standard geometrical proof. It's well written in NCERT. I would recommend you to go through that. Clear?
Yes, sir.
Okay, students. So all the best. I hope you understood the kind of questions that come in your examination. Yes, students?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So go through these questions again. Practice more questions of the similar kind. And now you got an idea of what kind of questions can you expect in your PU final exams, right? And these 2 chapters are quite important, and trigonometry, as I told you, is one of the most important chapters in your first PUC. So by all means, you must take a lot of efforts in knowing the formula and doing enough number of sums of different types so that sums come from different areas you are able to solve without any difficulty. All right?
Yes, sir.
Yes.
Okay, students. So wish you all the best. Have a wonderful night. Take care. Meet you in another session.
Thank you, sir.
Thank you, sir.
Bye, students.